equations are always based on inverses, even something as simple as like 2x plus 1 equals 11. We are essentially, when we subtract 1 from both sides, we're using the fact that the inverse x plus 1, the inverse of f of that would be x minus 1. And when we divide both sides by 2, we're using the fact that if g of x equals 2x, that g inverse of x is equal to x over 2. So this entire equation is kind of like f of g of x equals 11. And then we do the inverse of f inverse of both sides. And the f inverses kind of cancel each other out. We get g of x equals f inverse of 11, which is 10. And then we do the g inverse of both sides, which ends up g inverse of g of x is x, and g inverse of 10, g inverse is x over 2. It's 5. So that's kind of, so trig, any equations are based on inverses, and trig equations also are. In last lesson we looked at inverses, so let's see how this works. Now, if you have an equation like sine x equals 0.6561. Now this is going to have two answers, and the reference angle, we look up, if we have a trig chart or on a calculator, sine inverse of 0.6561 would be 41 degrees. But sine x, depending on whether you're picturing it this way, sine x, or whether you're picturing it this way, either way, there are two answers. One's between 0 and 180. So that's the reference angle answer. And the other answer is one's between 0 and 90, sorry. The other one's between 90 and 180. So for this quadrant, it's 180 minus reference angle, which is 139 degrees. Same thing with cosine. Cosine is 0.9. So there's two answers. One's going to be between 0 and 90. One's going to be between 270 and 360. The reference angle is 27 degrees. So the answers are going to be 27 and 360 minus 27 equals 333. Now when you have negative values, like that. Now that also has two answers. I think of them as being down here. We say the reference angle is sine inverse. I'm not going to put negative 0.6561 because we saw in the last thing that sine inverse of negative is a negative angle. It's between 0 and negative 90, or negative 90 and 0. So instead, the reference angle is still, it's going to be the absolute value of this thing. That's what I would type into a calculator. I would not type sine inverse of negative 0.6561. That's not going to give me a very useful thing. But this one would tell me the angle was 41. But now we know that 41 is just the reference angle. So the two answers are 180 plus 41 and 360 minus 41. So I guess the moral of the story is what you put into the calculator is sine inverse of positive 0.6561, even if this thing is negative. Same thing with cosine. So this equation, we first find the reference angle, which is cosine inverse of 0.8910. That's positive 0.8910, which becomes 27. Now 27 is not the answer to the question. Cosine is negative in quadrants 2 and 3. So the answers are 180 minus 27 and 180 plus 27. Notice that if I were to put into the calculator cosine inverse of negative 0.8910, it would say 153, which is kind of good. It's one of the answers. But to get this 207, it's not so useful. I have to then think, what's the reference angle? So a better thing to do is to put positive 0.8910 into the calculator, and out comes your reference angle, and your reference angle leads you to both answers. There's also inverse tangent. So the way I would do this question is my reference angle is tan inverse of regular 1.2799. It turns out that tan inverse has a range of negative 90 to 90, just like sine inverse does. So I don't want to put a negative here. That's going to give me something between negative 90 and 0. Instead, I put positive there. I know this is not going to be the answer, either of the answers to this question, and that's okay. The reference angle is 52 degrees, and tangent is negative in quadrants 2 and 4, so the answers are, the quadrant 2 answer is 180 minus 52, which is 128, and the quadrant 4 answer is 360 minus 52, which is 308. Okay. Again, the moral of the story is, into your calculator to do tan inverse of positive. If you don't have a calculator and you have a trig chart, that's your only option anyway. Sometimes you have a more involved equation, like this. So you isolate the sine x. Now, this is going to have two answers. We could even think of the sine curve this way. It's going to have two answers here, quadrant 3 and quadrant 4. But I'm going to put into the calculator sine inverse of regular 2/3. I know that's not going to be either of the answers for x. It's going to be 42 degrees. But it's going to lead me to the two answers, 180 plus 42 and 360 minus 42. We can see that this equation is basically the intersection of y equals 3 sine x plus 2 and y equals 0. So that would also be, those two answers would also be the answer for what are the x-intercepts. Again, those are 222 and 318. So here's sort of an extreme version of this question. We want to isolate the sine expression first, so we subtract 1. We get 4 sine bracket 3 parentheses x minus 20, close parentheses, close brackets, equals 3. Divide both sides by 4. Sine bracket 3 parentheses x minus 20 equals 0.75. Now we, on a calculator, do sine inverse of 0.75. We would do that even if this was negative, but it's not, so we're not tempted to do anything other than put sine inverse of 0.75, and we get 49 degrees. Now if this thing here were just a big X, we would say that that equals 49 and 130, or 131, because sine is positive in quadrants 1 and 2. But it's not X that's 49 or 131, it's this entire expression. So now we get the equation 3 parentheses x minus 20 equals 49, or 3 parentheses x minus 20 equals 131. Now we have to solve those by dividing by 3. X minus 20 is about 16, or x equals 36. And here we have x minus 20 is equal to about 44, or x is equal to about 64. So these are the two sort of more obvious answers. But actually, there aren't just two answers to this question. And I want answers that are between 0 and 360. So usually there's two answers. But if there's a number out here, what happens is that the curve gets sort of smushed. So I end up with more answers. And general rule, it's 2 times b, which is 6 answers. So the trick, so far we have two answers, equals 36, and x equals 64. The trick to getting the other answers is to realize that since the b value was 3, it was sine of 3x minus 20. So if I were to graph this, each of these periods would be 120 degrees. That's 360 divided by 3 is 120. So the other answers are going to be 120 past these two answers, and then another 120 past those. So if I add 120 to 36, I get 156, and if I add 120 to that, I get 276. Now I've got three answers between 0 and 360, and if I add 120 to this, I get 184, which is also an answer, and if I add 120 to that, I get 304. So I actually get 6 answers to this question. That agrees with the whole, if I squeeze these into 360, I should get 6 answers. Okay, so that's how you solve trig equations, including ones where there's more than 2 answers because of a b value that's bigger than 1.